Now, I'm a guitar player, and it's one of my favorite guitars. If I play a simple guitar chord, right, sounds nice. But look what happens if the guitar, because the guitar is a tempered instrument, and it does not come out of the factory necessarily well tuned. So we need to take care of it, right? So if I now look what happens when I detune it. So it's out of tune, right? We have a saying, guitar players spend half of their lives playing the guitar and the other half tuning the guitar. The guitar is a very finicky instrument and we have to tune it, right? And we do it actually by turning these knobs, right? If I turn it this way, the pitch goes up, or that way slackens, right? So now I'm trying to tune it up to this note that will resonate well with the rest of the chord. Nice. Sounds good. I detune. Bad. Why am I doing this? Am I losing my mind after my second dose of COVID vaccine? I want to ask you to imagine if anytime we need to tune the guitar, we need to write a program. So we don't have direct access to this. We need to write a program, computer program, that we then have to commit and open the PR, blah, 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 compile and build, and the code review, and PR gets approved, gets merged, the CI pipeline runs, and on it goes until actually the code we wrote reaches that machinery that's going to turn this knob, right? And then only that, at that point, do we hear, is it correct or not? And then we may say, oh, still not good. Go back, modify your program, do the song and dance, run through all the approvals and things and pipelines and whatnot, workflow, change management, blah, blah, blah. Now, if this was the only way to tune the guitar, how many people in the world do you think would be still interested in playing the guitar? Not many, only masochists. And because musicians are not masochists, luckily we have this direct. So, and also imagine if, not only that, but imagine if we had, this is a dev guitar, and then there is a system test guitar, or maybe there's a staging guitar and user acceptance guitar, and it has to go through all of these things until it goes into the real guitar on the stage, and then we learn, oh crap, this is not tuned well. So to me, that's like lunacy, right? But when you think about it, this is how we develop software. And it's just like, to me, unimaginable that we are so super tolerant to this situation. Like, why are we tolerating this? It takes forever. I make a diff. I have no idea how that diff is actually going to pan out once we go live, right? And there's always these unpleasant surprises. And that's why I was impressed by Raghunath's talk, where he drew our attention to that. Like, look, the longer we wait from the moment we make a diff until the moment we realize, did it work? Did it not work? The longer we're staying in dark, and the longer we feel demoralized, and it's not a fun job to be in. And so TDD is one approach how to shorten that, as we've seen today. There's many brilliant examples that we were looking at today that illustrates the importance of shortening the feedback loop. Because if we stay in this state of tolerance, then whatever we deliver is going to be really shoddy, in my opinion. I apologize. I know there are some geniuses, but overall, I'm coaching and training teams and whatnot, and you can see that if from the moment you make a difference until they actually eventually weeks later see whether it's working or not, that energy is gone, and we are kind of trudging through our daily routine, but it's not exciting. And here we saw today, which I think was a state of the art, a whole bunch of
13 talks, just blown away, starting from Jipa and James, and then, Elena, Ola, Liz, Meenakshi, and all that. Really opens up the door and the possibility of us raising the bar and going to the breakthrough, and getting to the point where we can really be real pros and start really delivering quality fast instead of going through all the song and dance. Now, of course, people are saying, yeah, well, it's easier said than done. And when you think about it, the real problem boils down to code as text, because text is our second nature. We understand text, and computers have no idea what text is. And so there's this kind of a cognitive dissonance between humans and machines where, yeah, I can roll with text and blah, 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 but then for the computer to actually run it, there's a little bit of a in-between layering. I'm a big fan of Kent Beck. To me, Kent Beck just blows my mind. And he is working on so many things and so many interesting ideas that it's such a fertile mind, right? And I don't know if you guys follow him, but basically what we're trying to do, we're trying to get to the point where each keystroke is deployed to production. Now, some people say, oh, that's madness, blah, blah, blah. Have you ever worked in Google Docs, like collaborating? That's it. You have a document or a spreadsheet or whatever, and you can have few people, and they are actually making it. Each keystroke is going live, right? So it's possible, right? What's stopping us right now is, documents is one thing, but computer, the syntax, abstract syntax tree that needs to be translated into machine code. And Kent Beck has these rules, like you should be able to make a diff and not harming anyone on your team, right? So that's a topic for another conversation today. And I'm going to put this guitar away. Thank you very much for indulging me. I apologize for my lousy playing. I'm going to try and walk you through how I do these things. I have been experimenting a lot, and of course, I'm teaching a lot. So I'm not a tool jockey, right? I'm not just heads-on cranking code. I'm doing a lot of research and teaching and coaching teams, and a lot of them are like novices or kind of trying these things out. So I like to keep things really bare bones simple, because sometimes if we do some fancy tools and they're doing a lot of magic for us behind the scenes, then people stop thinking, oh, I'm just going to push this button, everything is arranged for me. And that is sometimes counterproductive. So I'm going to try and share my screen here, if you don't mind. And all righty. And let me go here. Now, if somebody can ping me on WhatsApp whether my screen is showing, I would appreciate that, because I don't have a way of knowing. But hopefully you can see it. And if you remember, when I was doing my opening talk this morning, I was explaining how when I was a young programmer, I was doing a lot of just straight down coding, heads down. I was so cocky and brash, and I'm like, I know what I'm doing. And thinking back, that felt like this picture. This is the picture of a boy flying a kite. The kite, it's exhilarating experience, but it's very hard to control. And you're up in the air, and it's going every which and every way. It's blowing by the wind. Only, very hard to control it, and also very hard to figure out where to land it, right? And so I was very rarely trying to land my code. I would just be writing and entering and writing, and then later I tried to compile, etc. And after a while, I realized that this is getting me into trouble, because I was pushing a lot of bugs into production and people were screaming at me. And so, to cut long story short again, eventually bumped into extreme programming and TDD. So I switched my practice to TDD. And to me, can you see my screen? One sec. Yes, thank you. Okay, I don't want to talk into darkness. So see, this picture here is riding a galloping horse. This is how TDD feels to me. you're going fast. You are every now and then you're touching the ground, and then you are in flight. And when my thing about TDD, when I'm in flight, I cannot steer. The horse jumps, is flying through the air, it's like a straight arrow. I cannot change its direction. I only have a chance to change the direction when the horse temporarily touches the ground, and I can steer it. And so while this is fast and all that, something was not feeling completely satisfactory to me. And so, following Kent back and doing research and whatnot, I came to this point where I'm preferring to proceed like this. If you can see this picture of a tank. So why am I making things difficult? With experience and on the job software engineering, I grew to like steady state. I'm a big fan of steady state, which means I like status quo. I have aversion to change. As an engineer, I like my system to always be working. I don't like to see whatever I'm working on, I don't like to see it in a busted state. To me, that's very upsetting. So I kind of became the opposite of my younger self. And I value steady state. I know how brittle and difficult and fragile it is to build a good solid system. And as the saying goes, any resilient large system basically started as a very sturdy small system, and then step by step grew into that. It doesn't happen haphazardly. So in here, what I'm trying to do is I'm always grounded. Whatever happens, I'm on the ground. And so for that, I would like to have a system that heals itself. So I can go in and I'm stupid and I don't know what I'm doing. As James said rightly, you think you're a good programmer, but you're not. And definitely I'm not, right? I'm doing all kinds of stupid things. When I break something, I want my system to automatically heals itself. You go back into, no, everything's cool. We are still working. And again, I point back to Ron Jeffries. The trick is never to let the code not be working. The code must be working at all times. I don't like the situation, and Jupa talked about it a lot, where the system is busted and we are wasting hours messing around and the system is not up and running. And then somebody approaches you and says, what are you working on? Can you show me? And we're like, oh, give me like half a day. I just have to put some, connect some dots and put some things together, and I'll show you. No, you should be able to show them right away. Okay, here's what, how far we got on this at this point. Okay, so I hope this makes sense. I like this steady state, and I'm going to try and show how I now like to work. And for that, I came up with a very Mickey Mouse, super simplistic toy example, because we don't have much time and I don't want to bore you, and something that hopefully may illustrate this point. So I came up with a user story, and I'm calling it tip calculator because that's super simple. And I know these things exist, but just pretend we are going to build a brand new tip calculator, which story goes like, as a patron, I want to calculate the total bill, which is total plus the tip, because I want to compliment the restaurant for the service. So it happens all the time. I go to a restaurant, here's the bill, I want to give them a tip, and I have to calculate in my head, or maybe the machine, if the machine doesn't have the capability. And this user story, I broke it into about 5 scenarios, and let's just start with the first one, which goes like this. Scenario 1, patron calculates the total for terrible service. There's such thing as terrible service. Somebody spilled the soup on your brand new suit, they didn't apologize. Okay, these things happen. So now the given when then goes like this. Given that the restaurant total is $100 and the service was terrible, when the tip calculator calculates the total charge, then tip calculator shows $100 charge, which means no tip. I'm upset, I'm not impressed, no tip. So let's go and start building this. Okay. I'm going to create a directory, and I'm a terrible typist, so please don't be. So, and again, I like to bring, when I'm teaching, do everything from ground up. Nothing is pre-baked and whatnot, so that we, no ice up my sleeve and nothing like that. And I have this habit because I'm teaching a lot of novices, but I hope you don't mind. I know you're all amazing pros, but just please bear with me. I'm going to create this new tip calculator. This is going to be our solution. Sorry. And in here, the thing I like to do is I like to create tests. I'm big on tests. I love tests. And I'm using .NET because this is this demo was I prepared for .NET for my students. So I hope you don't mind, but you can do this in any tech stack, of course. So I'm going to create some commodities, and I'll be using XUnit. I like it. Nothing wrong with that. So this is going to build me a skeleton, a really simple one. And now I want to also create a shipping app where the code lives. The other one, oh, okay. All right. And again, I'm going to build a little bit of scaffold. A new class lib. All right. And now I'm going to initialize this repo. I'm going to add all. See, typo. Add all. Yeah, it's different in Linux. So okay. I hope you can see my, it's large enough, the font. And if I do get status, I need to commit. First commit, okay, nice. Okay, get status again. Clean. Let's go into the code. So you see here, we have app and tests. In the tests, it's given us some skeleton unit test. In the app, some Mickey Mouse class one. We can safely ignore it, doesn't matter. What I'm going to do now, and somebody please ping me if the font is too small. I hope it's not. See, first thing I'm going to do now, I'm going to teach this, and I'm doing it from ground up. So I'm going to teach this system how to self-heal. And the way I'm going to do it is I'm going to create some automation. So I'm going to say, I'm writing a script file, where I'm saying test underscore commit or reset. It's going to be PowerShell script because this is on the .NET, right? And this is in. Okay. Now here I'm going to tell this script to first thing to do to run .NET test. So I want you to run the test. Then when you finish running the test, I want you to check the last exit code, because two things can happen basically. Either tests are all in green and pass, or one or more tests fail. That's the only thing that may happen. I'm saying if your last exit code is 0, which means everything is in green, everything's cool, no worries, I want you to add all the diffs I made, and then I want you to commit with a message, the generic message working. And some people have qualms with this, but we can talk about that later. Else, I want, if the test, one or more tests fail, which means I broke the system, I want you to reset hard. And this reset hard is going to self-heal. It's going to pull me back to my healthy state. So this thing is now very simple, right? I believe it's self-evident. We run the test, check if it failed or pass. If it passes, add all the diffs, commit. If it fails, go back to healthy state. Very simple. Now, I want to, let me close the terminal. Let's quickly go into tests, because as we talked about earlier today, tests are the specification or where we declare expected behavior, unit of behavior. Mario had a brilliant talk on that, and I think everybody agreed. Now, here I am designing, and we talked briefly today about being careful how you name your tests and all these things are brilliant. And today I'm going to really rush through this because we don't have much time. But the first thing, what am I expecting the first thing from this tip calculator? Well, basically, if we think about all these like simplicity zombies and whatnot, we are now dealing with this terrible service with a terrible rating. So I'm gonna now cast my mind in that direction. So let me first think about terrible rating. What do I want system to do? I want the system to know about terrible rating. The system should know that there is such thing as terrible rating. And I'm expecting when I ask the system, is there such thing as terrible rating? The system will say, yep, I found it. So I'm going to call this test terrible rating is valid. And now how am I going to proceed? Fake it till you make it. Maxi told us hard coding is legit. Nobody goes to jail. I'm going to start, of course, with hard coding. And I'm going to say expected response for terrible rating is true. So this is how I'm daydreaming about this. I'm envisioning things here. I'm having my post-COVID visions. And my actual response for terrible rating is what is it? Is let's fake it. It's true. So I'm saying, yeah, of course. We're pretending that we have something that's still not there, and we're pretending everything's cool. The only thing left to be done here is to just assert for equality. Righty. So see, this is very, very naive, very Mickey Mouse, and we always start like very, very simple. So what happens when I save this? You see, the system runs that script. Oops. Of course. Demos. Test commit. Okay. What is the problem? Just see if things will. All right. Yeah, amazing how these things happen, right? So I'm saying, oopsie, no, assert. Equal. Apologies for this. All right. Okay, doc. Expected response for terrible rating is true, and actual response for terrible rating is also true. And now all right, let's see if this thing will actually behave. So once again, everything seems to be working fine. The gods of demo are smiling. I save. Okay. Sorry about that glitch. I have no idea what happened. So fake it till you make it. We're hard coding this. No big whoop. But you see, the system is not broken, even though it's not doing anything. Now, we want to replace this hard-coded true with some real code, and we need to point at the shipping code, which here in this, the CS proj for the test, I need to tell it where to look. And I'm going to say, look at the app folder for the app CS proj, right? Look, save. I go back to tests, and now I should be able to use it. Using app. And it finds it. Awesome. Thank you. You see, if I save now, system is not broken. Excellent. Now is the time for me to start designing this. And I like to always start from some kind of a abstraction. I like to use interfaces in C#. And I'm going to say, suppose there's an interface called tipCalculator. I'm going to call it tipcalc. And it is implemented by tipcalculator. So here's me daydreaming. I'm saying, look, I need some code to calculate these things. Of course, these two things don't exist. It doesn't look like I'm looking at the app. I can't find them. So my job now is to actually declare them. So I'm going to say, create a new file, tipcalculator. It's going to be C#. Namespace is going to be app. It's going to be public interface. I tipcalculator. Okay. If I flip over, okay, he finds I tipcalculator, but tipcalculator, its implementation is still not there. So I need to also declare that one. So I'm going to create a new file, tipcalculator.cs. I'll be using system here, and namespace will be app. The class is public, of course. It's called tipcalculator. And it implements iTipCalculator. And it's complaining because public class, yes. Okay, now we see that the declaration is happy, the implementation is happy, and empty, right? This guy's not happy. What's going on? Calculator. Now he's happy. Okay, typo. All right. We make mistakes. Awesome. Now there's a time where the rubber meets the tarmac, and we will have to now put this baby into use. So it's going to be tipcalc, and here I'm daydreaming again. I'm saying I want to send it a message, say, hey, is this rating valid? So I'm going to invent the new protocol. Sorry, I'm going to say is rating valid? Terrible. And this guy's complaining, saying, I don't know what is rating valid means, so we need to teach it. Here, I'm going to declare a new capability called isRatingValid, and it's going to return Boolean, true or false. I'm keeping things very primitive and simple. Don't get upset about it for the purposes. And then later on, of course, we will be refactoring. And now we need to implement this. isRatingValid for the string rating, and we must return bool, and I'm going to return true. So let's quickly go and examine. This guy's happy, this guy's happy, this guy's happy. What happens when you save all? Alrighty. The system is working, not in a broken state. But just, I like to always check what if I give it a false expectation. I'm expecting false. What happens then? Run again. It heals. It says, no. You failed and I'm going back to my healthy state. So the system is always in a steady state. All right, but we are cheating because this is hard-coded. Maxi told us it's okay, but we should not stop there. The next prime directive is refactor. And how do we refactor? We start again imagining. I'm going to say, okay, I need these tips to be stored somewhere in this calculator, and I'm thinking, rather than going fancy, I'm just going to use commodities that are available there. And of course, I know something about .NET, and I know for a fact that it has collections for free of charge. I'm going to ride on that. I'm going to bet on the horse called collections, and I'm going to say, you know what? I'm going to use one of the collections to store those ratings so that we can, calculate. And so what is the rating? It's a key value pair. Keys, for example, terrible, and the value is 0%. And then we have other values. So I'm going to use hash table, if you don't mind. It's very simple and primitive. We can later refactor, but for now, I'm staying with fake it till you make it. New hash table, and why is it complaining? I didn't give it a name. Let's call it tip percentage, plural, tip percentages. And let's see what happens when I save. Oh, didn't like something. Tip percentages. Okay, sorry about that. It always happens when I'm demoing. Using system collections, and then doing private hash table. I know I'm still a little bit under the weather. Apologies for that. All right, now we should be okay. If we run the system, it should not crash. So notice how I like to run the system as frequently as I can. I need to get this feedback, because if I stop doing this, if I just start adding code, I know I'm going to be in big trouble, right? So, all right, we have this, but now how do we actually tell it the values? And I'm going to here use just the, I know Max may be mad at me, but I'm going to use a constructor just for simplicity. And I'm just going to, what? I'm going to add variable, and I'm going to say 0, and that's it. Run again. Anytime I make a change, I run, right? And it seems idiotic here, but when you're dealing with some hairy things, it helps. And lastly, let's see how do we actually replace or refactor hard code into actual code. And I'm going to say tip percentages rating. So I'm going to ask it, why is it tip percentages? Sorry, my bad. The vaccine's kicking in. Contains key. So it's a nice commodity method. And why is it? Which key? Rating. Look, everything seems cool. If I run it, I hope I'm not boring you guys with this. All right, we're in a healthy state. And we have, right now, completed the first test. Yay. We have a strong system in the making. Now, I'm a big fan of symmetry. And then anytime I make something work, I'm always thinking, okay, let's flip it on its head. So my next expectation would be whatever rating is invalid. That's how I think. Maybe you call me a bit pessimistic, but I really like to go for some edge cases. And in here, I'm going to say that expected, I'm going to cheat a little bit. Expected response for whatever rating, and whatever could be anything that the system does not know, right, is false. I don't want the system being fooled by some glitch. And the actual And again, I love my, oh, sorry. I love to cheat. I'm going gingerly walking on eggshells. Equal, okay. So here I'm totally faking it. And of course, I'm expecting this to be in a healthy state. Yes, my system is running everything. All the tests passed, 2 tests, awesome. Now, I'm going to stop faking and I'm going to say, is rating valid? Whatever. What do you think is going to happen when I run? You guessed it. Yeah, it didn't find it, so it's false, which means the code is working. And I'm, again, being the old pessimist, I'm going to watch it heal itself. Yes, okay, back to normal. Alrighty. So I'm satisfied here. I'm like, yeah, okay, I have covered some edge case. I'm cool. I am now going to go one step further and think about the next expectation, which in my mind is that I need to convince myself that this system, when you give him terrible rating, has 0 tip percent. I need to know that. I want to be on the safe side, and I don't want any monkey business. Why? Because later on, this all of a sudden mushrooms is something else. It goes to another team, and they completely mess up, and all of a sudden our tip calculator starts being buggy. So I'm going to say expected. What did I say 9? Oh my god, it's weird. Expected tip for variable rating is 0. And I'm going to say actual tip for variable rating is also 0. Again, I'm faking. Equal actual. I run. I haste to run. I really want to run as much as I can. Alrighty. And now is the time to stop hard coding. We had our fun. And I'm going to say tip calc. Can you tell me if this rating has, what's the tip percentage? And it doesn't know. So I need to invent it now. So I'm like, get tip percent for variable. Yeah, I want to be able to send it message. See, I'm in charge here, right? I'm the god right now, and I'm saying, okay, I want you to do this. And he's saying, I don't know what it is. So I'm like, okay, just hang on here. I'm going to go to this guy and declare it. So I'm going to say int. We're going to use int, primitive, doesn't matter. Get tip percent for the string rating. Okay. I did go back, he's happy. The implementation is not happy. It's in red because I don't know how to do this. Okay, let me teach you. Get tip percent for string rating. This is what you're gonna do for now. Return 0. Fake it till you make it. Return, I know how to type. All right. Quickly, this guy's happy. This guy's happy. This guy's happy. We save all. And we are really shamelessly faking it, but the system is up and running. This is my prime directive in life. Now, awesome. Let's go back and say, yeah, okay, this is cool, but you are actually cheating. So now I'm going to actually try and return the real value for the rating. And of course, it is not integer, it's an object. First thing I want to do is I'm going to convert it to string. And then the magic trick is I'm going to parse that string for the integer. Simple, no big philosophy. And see what happens when I run. Yes, okay, the system is healthy. And now, just to appease my skepticism, what happens if I say, 190? Is it going to heal? I want to see it heal. Yes, I feel good. I like when I see these things. Like I said, I want the system always to go low. All right. We're inching our way toward having a nice tip calculator. I'm now thinking about what is my next expected behavior. So we know we can ask it if it has a rating. We know what the percentage is. Now we want to actually calculate the total. So we can say variable rating for 100, because if I flip over here, I say the restaurant total is $100 and the rating is terrible. So I'm saying $100 total is $100. So I'm saying here, if the total is $100 and the rating is terrible, then the total is $100. Oh, no, that's not it. I need to give it caliber rating for 100 is 100. Yes, okay. And now, again, I'm keeping things super duper simple. Expected total for variable 400 is $100, where actual total for variable rating is also $100. And here I have a typo. Sorry about that. Okay, and I'm going to assert expected to be equal to actual. I'm going to run. Everything's fake, everything works. And now replace hard-coded with, here we don't have any. So I need to, again, design here, and then I'm the, the maker, and I'm envisioning that this system should have some capability that I call calculate grand total for $100 and variable rating. And this guy says, I don't know what it is, and I'm going to declare it double primitive. Okay, apologies. But we can refactor. Calculate grand total for double total and for string rating. So declaration, test happy, finds it. Implementation not happy, doesn't know how to do it. Let me teach you. Public double. Calculate grand total for double total and for string rating. Let's fake it for now. $100. Quickly. Happy, happy, happy. Save all. Yes, okay. System is firing on all cylinders. Yes, some of them are fake, but we are inching away. We're going like really modest here. I'm the older I get more and more sheepish and modest. Alrighty, now is the time to replace hard-coded value with some decent, honest-to-God code. So first thing I want to have is the tip percent, which is give me for the rating. Next thing, I want to actually declare a grand total, and I want to calculate it on the spot by saying it's total plus the percentage, which is total divided by 100 times tip And lastly, I'm going to return grand total. And if I now run the system, yeah, works. So, my friends, we have solved, but not really. Wait a minute. Let's go back and say, what about those edge cases? Okay, let me tackle them now, because I want to be super paranoid. And I want to say public void whatever rating for $100 is 0. Why? Because it's invalid. You should not be calculating any positive values, because I have missed the space. Okay, so now I'm saying var expected total, like, or whatever, 0 var actual total for whatever, guess what? Also 0. Oh, sorry, I need okay. And keeping things brain dead simple as always. I love that. I'm not smart to go into any super duper adventures at this point in my life. I'm keeping it safe. All right, this is all hard coded. Here's when a system run. Oops, something was not happy. Let's see, was it a typo or something? Let me try again. I apologize for this. Public. It's coming to a close pretty soon, don't worry about it. Whatever rating is invalid, right? And we are saying var expected total or whatever is 0. Our actual total for whatever is 0. I'm going to assert equal did and actual. For some reason, it doesn't like this. Public void, whatever rating is, it already has defined. So we're saying whatever rating 100 is 0. All right. Cross fingers. Yep. Awesome. Now for the easy part, let's go and just like replace hard-coded with calculate grand total. We're saying $100. Rating is whatever. And what's going to happen now? Oops. System is broken. Oh my God, no. Not broken, of course, it healed, but we did not get as far as we hoped for. And now I'm thinking, when I look at it, the error, I'm saying, oh, so this is a null reference, right? Because we haven't really defined, if we go back to the tip calculator, I forgot that here, when we're getting the tip percent, we are counting on rating being there. It's not. And so this is a shoddy solution. It's bad. It sucks. How to fix it? Write another expectation. Never fix the code. When you see, this is one of the errors I will see, like, oh, I see where the problem is. You jump straight into code without writing test. Bad practice. Never do that. Always first write the code and tell yourself, whatever rating is -1% tip. If the system receives, for whatever reason, a glitch, some rating doesn't exist, -1 is a good catch-all, right? So I'm going to say var expected tip for whatever rating is -1, var actual tip for whatever rating is also -1. This is a fake. System runs and everything's cool. All right. Now we need to put it to work. Tip calc, get tip percent for whatever. Let's see what happens when we run this. Now it breaks. Yeah, it breaks because we haven't fixed it. Let me make sure we have a test. Whatever. Let me go here and let me say if is rating valid for rating. So I'm going to test, right? We have to know whether this thing exists or not. Then it's safe to return this guy. Else, return -1. See what happens now. Okay. Oh, sorry, we did not save. Oh. Yes, okie doke. Now is the time to go back to our calculate total for our grand total for whatever. See what happens now. Oh, it breaks. I mean, it's healed back, but why? Because it was expecting 0 and it got 99 because it subtracted -1. Okie doke. Let's fix that. So see, I'm going step by step. That's what makes me feel most comfortable. Some people think I'm really, but experience teaches me. Whatever. Okay. And in here, we're saying that, look, if the tip percent is equal to -1, just return 0. Don't worry. Let's save all. Yes, looking good. All righty. So you see, our system is now up and running. Everything's cool. We have solved the first scenario. What about the second scenario? It says same situation, total for poor service. And given $100, the poor service will result in $105 total charge. Basically 5%, right? All right. Never touch the code. Go straight to test. That's my mantra. I've been burned too many times forgetting about that. My next expectation is now riffing off the next scenario here that I received from the business. And I'm thinking, poor rating for $100 is 105, right? Makes sense. That makes sense. And I'm going to say var expected total for poor rating is 105. Our actual total for poor rating was 105. I assert, I go expected, actual, and I just want to see system is healthy, nothing changed. Alrighty, cool. Here I'm going to say tip calc calculates grand total for $100 for poor rating. Oh no, it was expecting 105, but it got 0 because it couldn't find poor. So the test, okay, we healed back, but I want to first do the test. Calculate grand total, sorry, for $100 poor. That's good. And I'm just going to go back here and say, well, yeah, I mean, the system doesn't know what terrible is, so we need to teach it. I'm going to say, look, there's another rating, which we call poor, and which is actually rated at 5%. Now, if I save all, awesome. So we now have a system that you can see calculates. And now, if I'm not experienced, I'm going to be excited. I'm going to say, all right, so if I go back and read other scenarios, scenario 3 says, for a good service, it's $110. For great service is $115. And for excellent service is $120, which is basically all 10, 15, 20%. I'm going to now, if I'm not being careful, and I'll show you why, I'm going to just add these things straight. No tests, nothing. Just go, you know what? I don't have time for this test. So I'm going to say, okay, good service. We're talking 10. Great service. We're talking 15%. Excellent service. We're talking 20%. What happens when I save? Yeah, works. Hey, you go back and say, look, this entire thing is implemented. No problem. Not so fast. I'm going to show you what I mean. And we talked about this today. I'm going to run mutation testing here, so bear with me. Called Striker for .NET. Oopsie. Typo, sorry. My brain is fried by now. It's been... So Striker is going to, and you know all about this, it's going to create mutants and blah, 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 and blah, blah, blah. And because it's running first time, it takes its sweet time. So it created 12 mutants and found 7 tests. Now it's going to run it. And it's going to do a full X-ray examination. And it's going to tell us that it found 12 mutants. It killed 9 of them and 3 survived. Let's look at the... So what do you mean survive? Like, this looks like squeaky clean solution. And I want to look into the report. And it's here, it's telling our success rate is 75%. I'm not happy with that. What's going on there? Ooh, you see, it's complaining about these guys. Saying if I replace good with a blank, no tests complain. And I do the same for great or for excellent, which means your system is very shoddy when it comes to understanding what are the ratings. And
Yeah, you may think this is not a big deal, but it is, because you can imagine this thing mushrooming into something else and blah blah blah, and all of a sudden we get a mess on our hands. And so, to conclude this, just because what I want to say here is just because all your system is up and running, all the tests pass, in my mind, that's not enough. I always like to finish the session by running mutation testing, and I want to kill all the mutants. How would we kill these mutants here? Basically, we'll have to go back to tests, and we will have to either test that these ratings have been declared to the system and that they have correct tip percentages. Only then would I say, yeah, this is a good to go system. You can take it to the bank. So with that, this concludes my hands-on presentation, and I hope I did not manage to confuse you. But this is all, again, moving or inching towards the system where we get super fast feedback. Now, I want to mention one other thing, and you guys probably know this, but if you follow Paul Bigger, and he's built this system called darklang, this is something to really examine and to have a look, because he is really working hard on minimizing and eliminating accidental complexity. And accidental complexity is the bane of our existence. And, I think we need to go in that direction to remove this long wait from I made a diff and then I don't know when I'm going to see if it works or not. TDD is a fantastic discipline. Today, we've pretty much laid it bare for everyone to see, to learn, to come to us. As I mentioned, we have a Discord channel. We talk like crazy about these things. And of course, all these other presenters have their phenomenal resources. And with that in mind, I think I'm ready to close the conference. I'm sorry, I had to switch computers, so it's not really, give me one sec. Just to go back into the saddle here. Okie doke. And the thing I want to do here, let's see. I want to say thank you all. And maybe you find me on Twitter and DM me, and I will link you up with the Discord channel.